Ka is equal to alpha square into C. For weak base, we write Kb is equal to alpha square into C. It is the relation between degree of dissociation म्हणजे alpha, dissociation constant म्हणजे Ka किंवा Kb for weak base आणि concentration means C. Amphoteric means dual nature. Hello and welcome back to SantChemistry. मी संतोष जाधव and I welcome you all to your favorite chemistry channel, SantChemistry. I hope you are awesome. Why? Because I am awesome. Okay, so now in this video we will go for the next topic of Ionic Equilibria chapter. Okay, in previous video we have discussed basics. Electrolyte काय असतात, what are electrolytes, their types, then acid base theories. Okay, now in this video we will be going for the next concept. Okay, amphoteric nature of water. So let's begin with amphoteric nature of water. सगळ्यात पहिल्यांदा what is meant by amphoteric nature? Amphoteric means dual nature. So water can behave, water has the ability to act as an acid as well as base. Water can behave as acid as well as base. That nature is called as amphoteric nature. म्हणजे तो as a acid as well as base behave करू शकतो. Water has the ability to act as acid as well as base. That is known as amphoteric nature of water. Is it simple? Yes. So let's see how. Amphoteric nature of water. Now, if imagine water is reacting with HCl. Now we know HCl is acid. Water is reacting with this. As per Arrhenius theory, what do we know? As per Arrhenius theory, H plus ion donor is acid, or also as per Bronsted-Lowry theory, H plus ion donor is acid. So HCl has H plus ion, so HCl can give it. If it gives that, what is formed? Cl minus. HCl ने H plus ion दिला, मग उरलं काय? Cl minus, बरोबर? And then the same H plus ion given by HCl is accepted by H2O. So here we get H3. 2 plus 1, 3, O, and since H plus is given to H3O plus. समझता है? Yes? Simple, right? So here, since water is reacting with acid, it should be a base. Case 1. And in second case, suppose if we react water with ammonia, NH3. In this case, water will act as acid. How? Simple. We know that ammonia has in ammonia nitrogen has a lone pair. Now water has H plus ions, so water donates H plus ion. जर पाण्याने H plus ion दिला तर उरलं काय? OH minus. समजतंय? Water gives H plus ion and what do we get? OH minus. मग इकडे OH minus मिळाला and the H plus ion from this here we have H plus and OH minus. OH minus ते उरला, हा H plus ion nitrogen ने accept केला. So we get NH3 plus 1, 4 and NH4 plus. Okay with this? Easy? Good. So since ammonia is a base, we know that water is donating H plus ions, hence it is acid. Clear hai? So water can behave as both. Water is behaving as both, as an acid as well as base. Hence we call it amphoteric. Amphoteric. Are we okay? Isn't this very simple topic? Indeed, right? Chala patkan note down this and then we'll move to the next topic. Chala patkan. Okay. Now the next is dissociation of acids and bases. Remember, strong acids ionize completely. हे आपण आधी बोललेलो आहे, राईट ना. सो स्ट्रॉंग ऍसिड्स आयनाइज कम्प्लिटली अँड वीक ऍसिड्स म्हणजे वीक इलेक्ट्रोलाइट्स आयनाइज पार्शियली टू अ स्मॉल एक्सटेंट. बरोबर. नाउ हियर when I say strong acid, we know strong acid, strong electrolyte will ionize completely. बरोबर. So HCl, example, HCl is a strong electrolyte. We use a single arrow, so it will form H plus Cl minus. बरोबर है. If I take 10 particles, 10 molecules of HCl, all 10 will ionize. That is called as complete ionization. Strong electrolyte. Same goes with this. NaOH forms Na plus OH minus. समजता है? गुड. कळालेला? ओके. इझी. यांचा सिंपल आपला पॉइंट काय आहे? व्हॉट वी वॉन्ट टू फोकस ऑन इज दिस एरो. दिस एरो इज इम्पॉर्टंट. ओके. म्हणजे इट्स अ फॉरवर्ड रिएक्शन ओनली, वन डिरेक्शनल. आयडियली हा चॅप्टर इक्विलिब्रियमचा आहे, राईट. आणि इक्विलिब्रियमसाठी काय कामाचं नाही आपल्या ते. बिकॉज टू स्टडी इक्विलिब्रियम, व्हॉट इज द मोस्ट इम्पॉर्टंट थिंग? Reversible reaction. Correct. We need a reaction to be reversible. Now let's consider weak acid. We know that weak acid हा कुठला acid नाही आहे. It is just example given. Okay. तर तुम्ही म्हणाल सर A कुठला एलिमेंट आला? We don't have any element as A. A is a random acid, so it will ionize as reversibly because it's a weak acid. So it will form H plus A minus. Ata, whenever we have reversible arrow, we can study equilibrium, and if we have equilibrium, we can write the equilibrium constant, right? Okay. Now equilibrium constant काय असतो? Equilibrium constant, if it is Kc, we write concentration of products upon concentration of reactants. बरोबर. Product upon reactant. Now here in this reaction, which one is product? H plus and A minus. Reactant is HA. So therefore we can say, आता इकडे we are writing Kc for concentration. For acid I am writing Ka. समजता है? Dissociation constant of acid. Concentration of H plus into concentration of A minus upon concentration of HA. समझते हैं? Dissociation constant of weak acid. Easy. Similarly we can write for weak base. If I say here weak base BOH, again it's a random dummy acid, we can say B plus. If it is as a base, it will give B plus and OH minus. Ha apla key point hai. If it is base, it will give OH minus ions. We got this. Therefore Kb is equal to concentration of B plus into concentration of OH minus upon concentration of BOH. If you want, I am keeping it here as a reference. इतपर्यंत समजते है? Yes. So what is the key point in this? Key point is reversible arrow. अरे सिलेक्ट पूर्ण केलं होतं. हा आता बरोबर आहे. हे काय जादू आहे? पूर्ण सिलेक्ट हो. हा आता ठीक आहे. ओके. सो नाव रिव्हर्सिबल आलं की आपलं काम आपल्याला तेच पाहिजे. बिकॉज दिस चॅप्टर इज अबाउट इक्विलिब्रियम and equilibrium is studied for a reversible reaction. Correct? Chala. Ata if you are comfortable with this, let's move to the next one, and that is Ostwald dilution law. एकदम भारी, एकदम interesting है. Focus properly. Let's quickly go for that. So let's begin with Ostwald dilution law. What is this law? Basically, it is the relation between degree of dissociation म्हणजे alpha, डिसोसिएशन कॉन्स्टंट म्हणजे Ka किंवा Kb फॉर वीक बेस आणि कॉन्सन्ट्रेशन मीन्स C. ओके. यांच्यातलं रिलेशन आपण इथे काढणार आहे. ठीक आहे. लेट्स गो फॉर इट नाउ. सगळ्यात पहिल्यांदा लेट मी जस्ट क्लिअर दिस. लेट्स गो विथ व्हेरी फर्स्ट वन. लेट्स गो फॉर weak acid. Now, if I say weak acid, let's consider any random acid. Consider a dissociation equilibrium म्हणू आपण. Dissociation equilibrium of weak acid, let's say HA. HA is a weak acid. How will this dissociate? आपण आता केलं ना, H plus and A minus, simple. So it will form reversibly H plus plus A minus. समजताय? Okay. आता if it is weak acid, if we are writing reversible arrow, what can be done? माहिती आपल्याला, dissociation constant. So let's write, therefore Ka is equal to concentration of H plus into concentration of A minus upon concentration of HA. याला आपण इक्वेशन नंबर 1 म्हणूया. Up to this point, if you have any query, please let me know. Okay? All okay? चलो, concentration of product upon concentration of reactant. आला आपला Ka. Now, let's move ahead. इथे if I say, if initially आपल्याला आता इथे अल्फा आणायचा, डिग्री ऑफ डिसोसिएशन. आपण एक काम केलं, वी हॅव इंट्रोड्यूस्ड डिसोसिएशन कॉन्स्टंट म्हणजे Ka. कॉन्सन्ट्रेशन स्क्वेअर ब्रॅकेट वी हॅव इंट्रोड्यूस्ड म्हणजे आपण कॉन्सन्ट्रेशन सुद्धा आणलं. आता उरलं काय, डिग्री ऑफ डिसोसिएशन. फॉर दॅट आय एम सेइंग, आय एम अज्युमिंग सम पॉइंट. सो इफ इनिशियली 1 mole of HA acid, 1 mole of HA was taken and alpha is the degree of dissociation. Okay, if alpha is the degree of dissociation, जर असं असेल तर पुढे काय असणार मग, आय होप इट इज विजिबल. याला आपण असं लिहून ठेवूया. ओके, इफ अल्फा इज दी डिग्री ऑफ डिसोसिएशन. नाउ लेट्स से इफ आई एम राइटिंग अगेन द रिएक्शन HA, थोड़ा सा राइट ला घेऊ, will reversibly ionize as H plus plus A minus. आता एक छोटासा आपण टेबल ड्रॉ करून घेऊया. This says initially, then at equilibrium, then concentration. Okay, now as we know, initially we have taken 1 mole of HA, so I am writing 1 mole initially. 1 mole, बरोबर ना, 1 mole, करेक्ट आहे. आउट ऑफ विच इनिशियली अजूनपर्यंत आयनायझेशन स्टार्ट झालंच नाहीये. सो ॲट द बिगिनिंग ऑफ आयनायझेशन देर विल बी 0 moles of H plus and there will be 0 moles of A minus. करेक्ट आहे. ओके, आता आउट ऑफ 1 mole अल्फा मोल्स आर गॉन. व्हॉट इट सेज, अल्फा इज द डिग्री ऑफ डिसोसिएशन. ओके, आता याचा अर्थ काय बघा. सपोज आय हॅव गिवन यू 100 रुपीज. ठीक आहे, आउट ऑफ 100 रुपीज यू हॅव स्पेंड 40 रुपीज. मग उरले किती, 100 minus 40 बरोबर 60. Similarly, imagine I have given you 100 rupees. Out of 100, you spent alpha rupees. Out of 100, alpha rupees are spent. उरले किती? 100 minus alpha. बरोबर? करेक्ट आहे? नाही कळलं तर रिवाइंड करून बघा. Out of 100, alpha rupees are gone. So remaining is 100 minus alpha. Similarly, out of 1 mole, alpha moles are gone. So remaining will be 1 minus alpha. आणि जेवढे हे कमी होणार तेवढेच हे वाढणार. राईट आहे? इफ 1 pen gives you 1 cap, then 100 pen gives you 100 cap. Similarly, if 1 pen gives you 1 cap, then alpha pens give you alpha caps. Simple. If alpha moles of this are dissociated, so alpha moles of H plus and alpha moles of A minus are formed. I hope you are with me. समझता है? Good. चला. So here alpha moles and here also alpha moles. Are we okay? Now let's put, आता हे concentration आपलं. Here we have number of moles. आपलं पाहिजे इथे concentration. So what is the concentration? Since concentration म्हणजे molarity is moles upon volume. Moles upon volume, and we already have moles here. जर आपण त्याला volume ने divide केलं तर आपलं काम झालं. बरोबर आहे? It will give you number of moles. मग आपण त्याला असं लिहूया, since concentration molarity is equal to moles upon volume, therefore here we'll say 1 minus alpha. 1 minus alpha divided by V will give you concentration of HA. Similarly, alpha upon V will give you concentration of H plus, and alpha upon V gives us concentration of A minus also. सर्वांना हे समजतंय? Yes. आता नेक्स्ट स्टेप काय असणार? Concentration values in equation number 1. Shabash. Let's see. Therefore, Ka is equal to concentration of H plus alpha upon V, concentration of A minus alpha upon V, concentration of HA 1 minus alpha upon V. Correct? So can we write this as alpha square upon V square upon 1 minus alpha upon V. So can we cancel alpha? एक minute, alpha नहीं. Can we cancel this V square and V? Yes. So now what remains? Therefore Ka is equal to alpha square upon V into 1 minus alpha. Okay, this is our point till now. I hope we all are okay with this. Yes. Ada, since alpha is very small, current degree of dissociation is very small amount. Out of 100 moles, hardly एखादा mole of weak electrolyte ionized होतो. याचा अर्थ alpha value is very small, and if alpha is very small, we can say therefore 1 minus alpha is approximately equal to 1. Okay, this 1 minus alpha becomes 1. Therefore we can say Ka is equal to alpha square, हा झाला 1, तो उरला फक्त V. Since initially 1 mole was taken, since initially 1 mole was taken, काय करणार आपण मग? Therefore 1 upon V, number of moles upon volume, number of moles upon volume 1 upon V is equal to C, concentration. समजतंय हे? जर याला आपण इक्वेशन नंबर 2 म्हटलं आणि त्याला 3 म्हणूया आपण. Therefore we can say from 2 and 3 what we can say is Ka is equal to alpha square into C, and that is an important equation. I know जरा confuse झाली आहे, पण प्लीज जरा सांभाळून घ्या. It is K is equal to alpha square into C. That is the final equation. जरा चेक करा, काही समजतंय का? कळत नसेल तर विचारायचं, ठीक आहे? Write that in comments if you have any query. We'll definitely try to answer. यातला अल्फा काय? Where alpha is equal to degree of dissociation, Ka is equal to dissociation constant, and C is equal to concentration. Are we okay? चला, टेक अ स्क्रीनशॉट किंवा लिहून घ्या, व्हिडिओ पॉज करून आत्ता लिहून घ्या. देन विल सॉल्व सम न्यूमेरिकल्स ऑन दिस टॉपिक. ओके, चला पटकन. हां, टेक्स्टबुक पेज नंबर 50, प्रॉब्लेम नंबर 3.1, सॉल्व्ड एक्झाम्पल. ओके, नाउ क्वेश्चन नंबर 1 is 3.1 is a weak monobasic acid is 0.05% dissociated in 0.02 molar solution. Calculate dissociation constant of the acid. If we have followed my previous videos, you know that we have a pattern of solving numerical. काय करतो आपण? Very first we find out what is given, then what to find, third formula, and the last will be putting values in the formula and solving it. Okay, chalo, if comfortable with this, let's try to solve this one also. Okay, आता इथे by the way इथे here we have for weak base also. weak base चा पार्ट मी नाही घेतला कारण कन्सेप्ट पूर्ण सेमच आहे. Ostwald dilution law for weak base is exactly carbon copy of weak acid. Instead of Ka we write Kb, म्हणजे ते असं येतं. आता आपण लिहिला Ka is equal to alpha square into C. For weak base we write Kb is equal to alpha square into C. Okay, फक्त एवढा फरक आहे. Instead of Ka, Kb, rest all exactly same. Okay, so for now let's solve this numerical problem 3.1. zoom होत नाहीये. So what is given here? A weak monobasic acid is 0.05% dissociated. So problem 3.1, given number 1 काय? 0.05% dissociated. If it 100% dissociates, strong acid or strong electrolyte. परसेंट 0.05% म्हणजे वीक इलेक्ट्रोलाइट आहे, बरोबर? हा, सही पकडे आहे. इथे पर्सेंटेज म्हणजे दिलं म्हणजे तो अल्फा असला पाहिजे. सो इट्स अ पर्सेंटेज अल्फा. समजतंय? किती 100% पैकी किती आयनाइज झाला? सॉरी फॉर दिस. 100% पैकी किती आयनाइज झाला हे आपल्याला कळतं फ्रॉम अल्फा. ओके, इट्स अ पर्सेंटेज अल्फा. Percent alpha is 0.05%. Number 2 given is dissociated in 0.02 molar solution. So concentration, molar म्हणजे concentration, okay, mole per dnq. So 0.02 molar. So for this I am writing 2 into 10 to the power minus 2 molar. काय केलं आपण इथे? 1 2. We have shifted decimal point to the right hand side. If decimal point goes to the right hand side, power becomes negative. 1 digit right side, 1 negative. 2 digit right side, 2 negative. Correct? Good. Okay. Now, what to find here? to find is calculate dissociation constant of the acid. Dissociation constant means Ka आपल्याला फाइंड करायचा इज इक्वल टू क्वेश्चन मार्क. ओके, आता याचा फॉर्म्युला काय? व्हॉट इज द फॉर्म्युला फॉर Ka फ्रॉम दिस अल्फा आणि सी? Ka इज इक्वल टू ओसवाल्ड डायल्यूशन लॉ, अल्फा स्क्वेअर इंटू सी. करेक्ट आहे? ओके, आता मला एक सिंपल सांगा, जर K इज इक्वल टू अल्फा स्क्वेअर इंटू सी, डू वी हॅव अल्फा हियर? अल्फा परसेंटेज येतो. मग इन सोल्यूशन very first point will be finding out alpha. So very first point is alpha is equal to, remember percent ला आपण जर डिवाइड केलं 100 ने, we get alpha value. So here percent alpha divided by 100 म्हणजेच आता आपण असं लिहूया, चला 0.05 upon 100. So we can write like this, 5 into 10 to the power minus 2 आणि हा पण वर जाईल 10 to the power minus 2. What do we get? 100 10 to the power 2. If it goes up, it becomes minus 2. Therefore, alpha is equal to 5 into minus 2 minus 4. First part done. Good. If the first part of this question is done, now the second part, alpha square into C. So second point is finding out Ka. Formula is alpha square into C. I have the value of alpha, 5 into 10 to the power minus 4, याचा स्क्वेअर करायचा आपल्याला, बरोबर ना? इंटू C is 2 into 10 to the power minus 2. आर वी ओके? आता करा मल्टिप्लाय, मग सोपं आहे, बरोबर? 5 square is 25 into 10 to the power minus 2 चा स्क्वेअर म्हणजेच मल्टिप्लाय बाय 2, 10 to the power minus 8, 4 to the 8, into 2 into 10 to the power minus 2. This will be multiplied, this will be multiplied. 25 2s are 50 into 10 to the power minus 8 minus 2 minus 10. Okay, and as per textbook the answer is, okay, can you shift केला point? So the answer given in textbook is, therefore Ka is equal to, याला आपण लिहूया 5 into 10 to the power 1 आणि हा minus 10. So 5 into 10 to the power minus 9 is the answer for Ka. समजतंय? Is this very simple? Yes? Good. बरं चला नोट करून घ्या और टेक अ स्क्रीनशॉट, तोपर्यंत आपण पुढचं पण करूया. ओके, डन? चला लेट्स गो फॉर दी वन मोर न्यूमेरिकल नाउ. नेक्स्ट न्यूमेरिकल आधी आपणला बंद करूया. लेट्स सी द न्यूमेरिकल प्रॉपरली. बघा, द न्यूमेरिकल सेज द डिसोसिएशन कॉन्स्टंट ऑफ NH4OH is 1.8 into 10 to the power minus 5. Calculate its degree of dissociation in 0.01 molar solution. Okay, so dissociation constant दिलेला आहे. Calculate degree of dissociation means, if you know the answer, pause and write answer in the comments. What is it? Alpha. Very good. So, and 0.01 molar means concentration is also given. So, Ka is given, C is given. आपला अल्फा काढायचा आहे. सिंपल आहे. चलो then, if yes, let's go for that. The dissociation constant म्हणजे 3.2 साठी given number 1 Ka dissociation constant base है ना, Kb लिहो अपन बघा. dissociation constant Kb is equal to 1.8 into 10 to the power minus 5. Okay, and second concentration C is equal to 0.01 molar. आता हे जर आपल्याला समजलं त्याच्या पुढे आपल्याला काय हवंय, व्हॉट टू फाइंड आउट, alpha, degree of dissociation means alpha. What is the solution for this? We know the formula is Ka is equal to alpha square into C. What is alpha square? Alpha square is equal to Ka upon C. And what is alpha? Under root of Ka upon C, right? So let's try to solve this. Okay, then after this, under root of, what is value of Ka? 1.8 into 10 to the power minus 5. What is C? त्याला आपण असं लिहूया, 1 into 10 to the power minus 2. जमेल ना? 1 into 10 to the power minus 2 molar. Correct है? Okay, if you get this now, हा खाली तो है, so what we get here is 1.2 into 10 to the power. If it goes up, it becomes minus 3. If we have so, we can solve further, is equal to 1.8 into 10 to the power minus 3 raised to 1 by 2, म्हणजेच स्क्वेअर रूट इज इक्वल टू, आता 1.8 चा स्क्वेअर आपण काढू शकतो, पण 10 टू द पॉवर मायनस 3 चा काढायचं म्हटलं तर प्रॉब्लेम होईल. बेटर इज लेट्स शिफ्ट द पॉइंट. तो इफ आई से 18 into 10 to the power minus 4 raised to half, so what remains? Square root of 18 is, you can check by using calci also atta, but exam साठी we have to use log table. By the way, in upcoming lectures we'll try to give you guidance about the log table also. I got some comments to explain log table, so we'll definitely do it as soon as possible. ठीक है, तोपर्यंत if you check log table, in that we have a square roots column. त्यामध्ये आपण चेक केलं तर square root of 18 comes out to be 4.242 into 10 to the power minus 4 divided by 2. So answer is minus 2. समझता है? That is our final answer for alpha. Okay, you can verify it here. An answer? Good. Simple. Chla. Take a screenshot of this, and if it is understood, we'll now move to the next question, because these two questions are exactly similar to the previous one. हा थोडा वेगळा आहे पण सिंपल आहे, and even this is quite simple. तरी कळलं नसेल तर please write that in comments. We'll definitely try to clear this topic also. Okay, chalo, I guess this is it for this video. If you like the video, please hit like button, and if you have any queries, write that in comments. Also share this video to all your friends. Let them also learn chemistry in easiest way. Okay, this is Santosh sir signing off for now. See you soon.